Hi guys. So what this video is going to be is it's going to be expanding on inverses. So we looked at this a little bit in class. This is just going to be some more information that we didn't have time to go over all the way in class because of the ACT day. Again, we hit kind of the high points of this during the class period. So those are some look back at some of those examples we did on your notes, but this is going to go over the rest of the notes. So with inverses, things to remember, okay? And this is the part we really focused on. For graphs, you are writing the ordered pairs, and then you are switching the x and the y. You do not need to change the plus and minus. You are only changing the x and the y, okay? Same thing when you're writing an equation. This is the part we're going to look at on the video. The x becomes y and the y becomes x, and then you just solve to get y by itself. Then specifically for square root and cube roots, so this is kind of the important new part for these particular functions. Domain and range are actually going to be flipped from each other. Okay, so the domain of the original is the range of the inverse, and vice versa. Okay, the range of the original is the domain of the inverse. And this is going to be very important for square root functions. So the way we're going to start for finding this inverse, okay, is we're going to list the domain of the original. So domain, left to right, the farthest to the left this graph goes is 0. It keeps going to infinity. Parenthesis on infinity, bracket on 0. Okay, range, bottom to top. This keeps going all the way to negative infinity, but then it stops at the highest point, which is 5. Now, I can write the domain and range for the inverse without even graphing it. So what happens here is what we just talked about at the end. The domain becomes the range. And the range becomes the domain. We don't need to flip the order of the numbers. We keep them exactly as they are, but the domain for one becomes the range for the other. All right, so now let's go ahead and actually graph our inverse. All right, so I'm going to list the points that I have here. So one of those points is 0, 5. I'm going to put it over here. There's some more space. Okay, so 0, 5 is one of my points. All right, another point I have is 1, 4. And then I'm going to list one more point to make this a little bit easier, and that point's going to be 4, 3. So what I'm going to do now is I'm going to write the points of my inverse. And to find my inverse, all I do is I switch x and y. And these are going to be the points that I plot on my new graph. So I'm going to plot 5, 0, 4, 1, and 3, 4. Connect my dots. And again, I've already done domain and range because I just flipped it from the original. All right, so if you feel comfortable, pause the video, try this one. Okay, otherwise we're going to keep going. Domain, again, left to right. So this is going to be -6 to infinity. Range, bottom to top. So this time we do know the lowest point. So it's going to be from 5 to infinity. Okay. The domain becomes the range. The range becomes the domain. All right, and then again, we just list our points, flip the x and y. So -6, 5 is going to become 5, -6. Okay, -5, 6 is going to become 6, -5. And then if I want one more point, I can use this one. So -2, 7. I'll write it down here. So -2, 7 is going to turn into 7, -2. Connect my dots, and there's my inverse. All right, so probably the hardest part about these is writing the equation of the inverse, okay? And these are going to be harder for square roots than they are for cube roots because of the domain. So the first thing I'm going to do is I'm going to list the domain and the range for the original function, okay? So my original function, the first thing I need to do to figure out domain and range is find my starting point. Well, this graph has gone left 3 and down 2, which means my starting point is at negative 3, 2. And then I need to look at the shape of the graph, see if it's been reflected. Okay, this graph has not been reflected, so it's going to look like my normal parent function, right? Which means I know the left point and I know the bottom point. The left point is negative 3. The bottom point is 2. And then the domain becomes the range, and the range becomes the domain. So once this is done, we're going to work this out very similar to the way we did with quadratics and inverses. Okay, so what we do is we switch x and y. So this becomes x equals the square root of y plus 3 minus 2. So I'm going to get the square root by itself first. So I'm going to add 2. And then to unsquare root something, I need to square it. Well, if I square the right, I have to square the left. And I'm going to leave this as x plus 2 squared, because if I'm writing a quadratic equation, this is how you guys are used to seeing it. And then to get y by itself, the last thing I need to do is subtract 3. And then I'm just going to rewrite this actually with the inverse notation. So this is f inverse of x. And it's x plus 2 squared minus 3. All right, so let's look at the next one. Again, I need to start by finding my starting point. I went right 5, down 8. And then this graph has been reflected over the x, so the shape is going to go down. So that does not change my domain. My domain, I still know the farthest left point. What I do not know is the bottom point. So this graph goes from negative infinity, and then negative 8 is actually the highest point it goes because of that reflection. Then once we know domain and range, okay, domain becomes the range. Range becomes the domain. And then we can solve. Okay, so flip x and y. Add 8. All right, and then the first thing I need to do is I need to get rid of that negative. Okay, so what I'm going to do is I'm going to multiply both sides by negative 1. Okay, if I multiply that by negative 1, it becomes positive. And then what I'm going to do is I'm going to put that negative outside my parentheses. Okay, and that's going to just be similar to the format you guys are used to seeing for those equations. Okay, so now I'm going to square it. Okay, I'm going to square the right side. I'm going to square everything on the left side. If I square a negative, it is no longer negative, so this is now positive. Then all I have to do is add 5, and I'm going to write it as an inverse. So it's going to be x plus 8 squared plus 5. All right, last one. Again, I'm going to do my domain and range. Okay, so this one would start at 7, 3, right 7 and up 3, has not been reflected or anything, looks like the parent function. So I know the farthest left is 7, the bottom is 3. Flip domain and range. All right, and then let's solve. Okay, switch x and y. Minus 3. And then I need to get rid of the 3 in front. Okay, so I can divide by 3, but instead of dividing by 3, another option is you can multiply by 1 over 3. And the reason I'm doing that is, again, just the notation is similar to what you see whenever you wrote your quadratic equations. So this is 1/3 x minus 3 equals the square root of y minus 7. Then to get rid of my square root, I would square, and again, I would square everything, including the 1/3. 1/3 squared, you square the top number and the bottom number. So this is 1 over 9 x minus 3 squared. add 7, and you have your inverse. All right, so we're going to do the same thing just with cube roots, and cube roots are much easier because we don't need to stress about domain and range because every cube root is going to be from negative infinity to infinity from domain and range. Okay, so again, to do the graph, these are the two we actually did together in class, so I'm going to go through these pretty quickly. I'm just going to rewrite those points and flip x and y. All right, so here are the original points, and again, just change x and y. So this is now -8, -6. Again, I'm not changing any of my positives or negatives. I'm just switching the x and the y. So there's -8, -6, -7, 1, -6, 2, -5, 3, and -4, 10. Connect your dots, and there's your inverse. All right, and then I'm going to do 7, same thing, write the points, flip x and y. All right, so here's my original points, and then I flip them, so 5, 10, 3, -3, 1, -2, -1, 1, and -3, 6. All right, and I realized I left off, that was a -10, 5, so that's 5, -10. All right, so once I've plotted my inverse points, just connect the dots. All right, so the last thing we're going to look at is finding the equation with cube root. So again, this is going to be a little bit easier because domain and range for both of these. Okay, I'm just going to write it in the middle because it's for both -infinity to infinity for all cube roots. So to find the inverse, I switch x and y. Okay, get y by itself, so -4. But instead of squaring, this time I'm going to cube because that is the opposite of cube rooting. Okay, I'm going to leave it in the parentheses. Add 3. And that's my graph. So this is f inverse of x, x minus 4 cubed plus 3. All right, again, if you feel pretty comfortable, pause the video, try this one on your own. But I'm going to go ahead and work this one out. Okay, switch x and y. Add 8. All right, I would, at this point, to get rid of that -2, okay, I'm going to multiply by -1/2. Okay, I'm going to leave it in that same form. Okay, then the only way to uncube is to cube. I'm going to cube everything over here. The only thing that's a little bit different, if you cube a negative number, it is still negative. Because if you do a negative times a negative times a negative, then it is still negative. And then you would just subtract 6, and you've got your inverse. All right, and those are inverse functions.